All right, here's problem number 4 of homework week 8. A study was done on body temperatures of men and women. The results are shown in the table right over here. Assume that the two samples are independent, simple random samples selected from normally distributed population, and do not assume that the population standard deviations are equal. Okay, use a 0.01 significance level for part A and B. In part A, they want me to test the claim that the men have a higher mean body temperature than the woman. So I'm testing claims about the mean of two populations using two samples. If you look at my week 8 lecture notes, I'm going to follow these steps here. The third way you can compare the mean of two populations. The third one, why I'm following that one, because I follow these steps when I'm working with independent samples. I mentioned that already. See, independent sample. I follow these steps also when I do not know sigma 1 and sigma 2. In other words, I do not know the standard deviation of each population. Nothing, no value, no number was given to me about how much is sigma 1 and sigma 2, the standard deviation of the population. It was not stated. And I will also follow these steps if I have unequal population variances, which is the same thing as saying do not assume that the population standard deviations are equal. So I'm going to follow these steps. Step number 1, make sure you do not know sigma 1 and sigma 2. I already said that. Still in step 1, another requirement I need to meet, that the samples are random. You can see here it says simple random sample. So far meeting the condition of step 1. Another thing, the samples are independent. Yes, it says that. It says it right here. And that the populations are normally distributed, and that is said right over here, normally distributed population. So step 1, I met the requirements. Now I'm going to go step 2. Let's translate the claim from words into math. So here's the claim, and I'm going to write it mathematically. Okay, and mathematically it says the men have a higher mean body temperature. So mu1 is going to be the mean body temperature for the men. Higher means greater than the mean body temperature of the woman. That will be mu2. Now that's my original claim, so let me write that here. Claim, that's my original claim. And every claim has a counterclaim, so it will be mu1 is less than or equal than mu2. But in our book, we don't write less than or equal, we're going to say equal. So mu1 is equal to mu2. And once you have the two claims, label them as HO and H1. Whatever claim has the equal is HO. Okay, whatever claim doesn't have the equal is H1 or HA. And I did step number 2. Step 3, I'm going to find alpha, who is my significance level. Okay, my alpha. And my alpha, you can see up here, is 0.01 significance level. That's my alpha. And I did step 2. Step 3 is, oops, I opened this by accident. Let me close that. Step 3, I'm sorry, that was step 3, alpha. Step 4, we're going to find the degrees of freedom. And because we had two samples, we had to choose the degrees of freedom that comes the smallest. Now, because my two samples are different, so I'm going to have 2 degrees of freedom, DF1. That's from the man, and the man there was 11, so 11 minus 1, that will be 10. Degrees of freedom 2, that will be for the woman, and the woman, there were 59 women, so 59 minus 1, that will be 58. Which one is the smallest? 10. So that's going to be my degrees of freedom that I'm going to be using the rest of the way. Okay, and I did step 4. Step 5, I'm going to do the picture, the bell-shaped curve. Okay, so here is the bell shape. I need to shade a tail. One tail or two tail? Who decide that? H1. And because H1 has a greater than symbol, that means pointing to the right. I'm shading the right tail. So this is what I'm shading. All right, and that's step 5. Step 6, that's when I have to calculate what is called the test statistic. So I'm using this formula. So I'm going to find t equal. Now to find t, what I'm going to do is I'm going to move this to the side. I need to plug in this formula all the information that I have here. All right, so let me get decimals, pull it out here. There it is. Let me make it a little bit smaller so you can see. All right, I'm going to put this formula in decimal. So I'll click the fraction, parentheses, here we go. X bar 1, that will be 97.59 minus X bar 2, 97.33. Close the parentheses. Minus, now it comes mu 1 minus mu 2. Now, because we always assume that mu 1 is equal to mu 2, when you subtract, this is 0. That's why I'm putting 0 there. Over the square root of, now I'm going to have a fraction, S1, which is the standard deviation of the man, 0.81. And don't forget, you have to square that. Over the sample size, which is 11, plus, again, we're going to do now S2. So fraction S2, 0.71, that's the standard deviation of the woman. I had to square that over the sample size, 59. And there is your T, your test statistic. Now, most likely they want me to round to 2 decimal places. When I round this, it's going to come out to be 2. Okay, I'm sorry, not 2. Look at me. Let me look it up again. 1. Okay, so this is 1.00. Let me make sure again. Why 1? Because 2 decimal places, I have 0.99. I have a 5 after the 0.99. I go 1 up, it becomes 1.00. And I did step number, let me put this over here so we can see that. We did step number 6. Step number 7, that's when we find the p-value. How? We're going to use the p-value t calculator, which is this one. Okay, and what I'm going to put in, my degrees of freedom. What was my degrees of freedom? The smallest one out of these two here. So 10. What was my t-value? That's what we just did. 1. Calculate. And you're going to have 3 answers. Which one you're going to use depending on your picture. Okay, because it's shaded to the right, 1 tail, you're choosing the first one, so your p-value, usually we're going to round to 3 decimal places, is 0.170. Okay, and we did step number 7. Step number 8, that's when we make the decision. We're going to compare the p-value against the alpha. My p-value is 0.170. My alpha, 0.01. See, you get it from here. That's the alpha, and this is the p. And from left to right, 0.170 is bigger than 0.01. What will be our decision based on what it says here? Our decision is going to be fail to reject HO. Okay? That's what's going to be here. And I did step number, whoops, where did it go? Right there. I did step number, I think it was 8. Now we're going to do step 9, the interpretation. And I need, what was my decision? So it failed to reject. I'm in the second row. Where is my claim? My claim is in H1. So the last column, so second row, last column, the intersection, whatever it says in the intersection, that's my interpretation. It says not enough evidence to support the claim. Okay, so not enough to support the claim. All right, now I did everything by hand. I'm gonna go and put all of this in my answer, okay? So first thing, I need to identify the hypothesis. So which of these 4 options look like this? Letter D. See, I'm going to check my answer. The next thing they're going to ask me is the test statistic. And what was my test statistic? That's the T, the value of T. We got that is 1. It says here 2 decimal places, so 1.00. I'm going to check my answer. All right. The next thing is my p-value. So my p-value, you can see it right there. So 3 decimal places. So 0.170, and check your answer. The next thing is the conclusion. So it involves two things, the decision and the interpretation. So my decision was failed to reject, so it's between letter C or D. Which one I choose? The one that says not enough evidence to support the claim. So that will be letter D, and I check my answer. Okay, now I'm gonna do the interval, constructing the confidence interval. And to do that, okay, let me go down here. I'm gonna have to make this a little bit bigger so I can write my work. All right, I need to construct the interval. Okay, I need to find E first. And how do I find E? E is TC times S1 square over N plus S2 square over, I forgot this is N1 over N2. Okay. First, we need to find TC. How do we find TC? Well, I need to know the confidence interval, okay, the confidence level. Now, the only thing I have here is that it says here, use a 0.01 significance level. So to find the confidence level, the C, you're going to do 1 minus 2 alpha. Who is alpha? We already know, 0.01. You can see it from up here. So this is 1 minus 2 times 0.01. So when you work this out, you're going to get 0.98. That's my confidence level. All right. So how do you find the TC? Okay, the TC for 0.98. Well, that's when you're going to have to go to another calculator that we did in week 5, which is this calculator, the T calculator. You're going to put the degrees of freedom, which we already said is the smallest one, 10. And my probability level, remember that my probability level was 1 minus C. If my C is 0.98, 1 minus 0.98 is 0.02. Okay, so when I go to here, I'm going to put 0.02 and you click calculate. And you're going to get two answers. Remember, you always use the two-tail because when you're working with confidence intervals, you have two-tail. And I'm going to use 3 decimal places, so 2.764, okay? That's my TC, 2.764. I just want to confirm that I put the right number in there. Yes, okay, good. Let's keep, let me minimize this so I have more space. Now I'm going to find the two boxes, see? You have something like this in my stat lab. I need to find out what do I write in the left box, what I write in the left box, and in the right box. In the left box, you're going to write x bar 1 minus x bar 2, close the parenthesis, minus E. And in the right box is x bar 1 minus x bar 2 plus E. And now what I'm going to do, I'm going to put this on the side. I'm going to use my decimals calculator that I know I have it open right there. I'm going to clean this up. All right. And I need to find E first. I don't have E. I told you we're going to use this formula here to find E. So E equal. Now I'm going to do it in decimals. It's much easier for me. So TC 2.764 times the square root. Now I have to do S1. Okay, so 0.81 square. See, that's S1. But I have to square it over N1, which is 11. Plus, now another fraction, S2, 0.71 square over N2, which is 59. That's how much is my E? 0.722. Let me write it here. 0.722. Now I'm going to use my decimal calculator to find the left box and the right box because I already have x1 and x2 from here. And my E. So let's do it. So here we go. X bar 1, 97.59 minus X bar 2, 97.33. Close the parenthesis. Minus E. How much is my E? 0.722. Look what I got. Negative 0.462. That's what I'm going to write here. Negative 0.462. This is a 0, by the way. All right. Now let's find the right box. Now the only thing I have to do is change this to a plus. And it's 0.982. All right. And that's what I'm going to type in my answer here. So let's do that. Negative 0.462. Let me double check I put that correctly. Yeah. And on the other one is 0.982. All right. And again, I'm going to double check I put that correctly. Good. And now I'm going to check my answer. There you go. That's how you do that. All right. I hope this helps.